In digital signal processing, the audio signals are transformed into a series of pulses that correspond to patterns of binary digits. In its system, the sound is stored and manipulated as a stream of discrete numbers, which each of the numbers is representing the air pressure of a particular time. In this particular project, the students are needed to produce a signal waveform from the 5 seconds of voice recording of the word UTHM FKEE. Thus, the sampling frequency of the project used is 11 kHz, which precisely 11,035 Hz. The objectives of the project are to produce a signal waveform from the voice recording by using MATLAB software. Next is to plot signal of the word M by using retrieved data, which obtained from the signal. The third objective is to decimate and amplify the retrieved data by 510 respectively. Last but not least, to produce magnitude and phase spectrum of the signal, which the decimated signal is calculated by using Z-transform technique.
Hello, Assalamualaikum. My name is Muhammad Alif Bazli bin Bukhari. My matrix number is DE180134. So here I am presenting about the flowchart. So we know that the flowchart is the important part in the project. We must to know the flow of the project. So I will go one by one of the block diagram. So first is about the start and go to the record audio UTHM FKEE. So this is the input of this project. So next, the process of word in the sinusoidal and plot the graph, we get the graph. And next we go to the retrieve word M. So if we get the word of M, we must go to the next process, and if we did not get the word of M, we must go back to the process word in sinusoidal until we get the word of M. So next, if yes, we must go to we get the plot sinusoidal and discrete in word M, and decimate the retrieved data by 500 and amplify it by 10 in the process block diagram. So next is about we get the output, plot the signal, we get the signal, and we'll calculate the spectrum of the decimated signal using Z-transform technique. We must go to the process, and then we get the display of Z-transform in the output plot diagram and calculate the magnitude and phase spectrum. And we go to the last part, which is we get the magnitude and phase spectrum of the signal as a output. So the last background is about the N. So as I tell from the one into the last, all the calculation, all the display of the graph of the signal will be showing in the result and discussion part. That's all. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Binuddin. So today I will present about the project of the DSP for part simulation. Okay, this is for our coding. And this is for the record audio for UTHM FKEE. So I don't want to create a new audio because it will change all my result in my report. So Y is I declare Y to get the data of the record. You can hear the sound here. Never mind, I just copy here. You can see the sound.
UTHM FKEE.
So this is for the graph of UTHM FKEE. UTHM FKEE. So we get all the sample of the UTHM FKEE is 55,125 sample, we can see here all the data until 55,125 here. Okay, this is for the original audio, and this coding for the retrieve word M from the original video. So we can hear the sound M, and again this include the graph word M. This for the sinusoidal, and this is graph in discrete word M versus sample, and discrete original word versus sample. And the sample of word M is 6,141. We can see here all the sample until 6,141. Okay. Oh, before I forget, how can I get word M? Here we can see UTHM. M start from 2.86 second until 2.7 second. Just random. Just a random value. If not fixed, it's not fit, you can try again. You can try an error until you get the word M clearly. Okay. Here graph. So this graph for the decimate. So this is for the formula of decimation signal by 500, and this graph for the amplifier signal by 10. So we can see the graph. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the sample number of the word Y after decimate by 500 is 13, and after amplify by 10 also 15 sample. 13 sample. Sorry. Here, and I will show you. Next, for the Z transform. This is coding for Z transform. So this is our value or answer. You can see here. So we can see here N equal to 13, I equal to 13. So means that we have 13 sample of Z transform. So 1, 2, 3 until 12, 13. Okay. Next, this is for our coding for phase and magnitude. So just copy and paste, and we can get the data and the phase and magnitude. So this is for magnitude spectrum graph, and this is graph for phase spectrum. So we can prove here. We can wait, I clean this, and we can write the command. You can see I'm writing the command on the command window. I want to complex, single complex, enter. So we can get 0.8896. so this is single for magnitude, single magnitude, and this is single for phase. So we can compare the value to the result. So here first, negative 61.0161. Here we can see negative 61.0161, and the phase 0. So we can see here phase is 0, so it means that it's proof to my simulation. So I'm totally done for all the simulation. So we can compare the simulation part with manual calculation. So we will compare just a little bit. Wait, this DSP. Handy for the MATLAB. So we can compare the magnitude and phase. I'm just proof one sample only, and all the totally same. So we can get the Z transform of the complex here 0.8896. The phase the imaginary is 0. So I prove it here. When frequency is 0 and when the omega is 0, the Z transform will produce 0.008896 plus 0 imaginary. This because we can see here 1 times exponent -3 means that 10 times power -3. So when you use calculator, 0.8896 times 0 10 power of 3, we can get 0.008896. So I prove here the result is same with the simulation. For the Z transform, for the complex, and magnitude is in dB. For the complex, we can get the magnitude. So this is our calculation, and this is for the simulation. So we can get the magnitude negative 60.0161 dB. So here proof negative 61.0161, and this is for phase. Phase imaginary over real, stand inverse imaginary over real. So we can get 0 phase. So here 0 phase. So I'm just compare with my manual simulation, manual only for one sample. So means that for the rest is totally same. Manual calculation is totally same with my simulation, because for the first sample is same with my simulation. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nizamullah bin Mahmud. I will present result and analysis. In this project, we record voice saying UTHM FKE in about 5 seconds using audio recorder function in MATLAB with the sampling frequency is 11025 Hz. So from the recorded audio, the word M are retrieved and then decimate and amplify by 510 respectively. We then calculate the spectrum of the decimated signal using the Z transform technique. For the audio recording process, recording is like this. The audio recorder, this is the sample frequency, number of bit and the channel. Record A5 means we record the voice for 5 seconds and return the recorded audio to the MATLAB workspace, sign Y to play the recorded data, and we plot the signal. So this is the signal of the voice saying UTHM FKE. Recorded audio, we retrieve the word M. So the word M are recorded from 2.086 second until 2.7 second. So this is the coding. To retrieve the word M, we name the retrieve data as Y1 from 2.086 second until 2.7 second. Sign Y to play the data retrieve, and we plot the signal of the data retrieve. From the data retrieve, you are required to decimate the data by 500 and amplify it by 10. But the data in analog signal, so we convert to the discrete signal first. To convert the data into the discrete signal, we use coding stem Y1. So, so, so this is the discrete time signal of a retrieved data. We name the process of decimation as C, and we decimate for 500 and plot as time C to generate as a discrete signal. For D is the amplification process by 10, and we plot this time D to generate the discrete signal. The first row is the graph for decimation by 500, and the second row is the amplify by 10. The Z transform can be obtained by applying formula of one side or causal Z transform. This is the formula. This is the coding to get the equation in Z transform. Figure 5 show equation of the signal in Z transform. We rewrite the equation of Z transform. So this is the equation. For the magnitude and phase spectrum can be calculated using formula of magnitude and formula of phase. This is the coding for right in MATLAB to obtain the magnitude and phase spectrum. So the frequency used to obtain the magnitude and phase spectrum is from 0 to 5 kHz. Figure 6 show the answer of the magnitude and phase. The magnitude and phase then are plotted in a discrete signal using this formula. And the first row is the magnitude spectrum, and the second row is the phase spectrum. To prove the simulation, we do manual calculation for Z for frequency equal to 0, then the angular frequency equal to 0 too. And we get the magnitude equal to negative 60.0191 dB and the phase equal to 0 degree. So by referring to the answer in the magnitude and the phase for 0 Hz, the magnitude is negative 91.0161 and the phase is 0. Okay, this is the answer.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rashid Ruzani bin Azmi, metric card number DE180200. Okay, so in conclusion, in this project, we are able to record data of the voice saying UTH-M FKEE using MATLAB function, which is audio recorder. So the original audio signal record for UTH-M FKE in 5 seconds with sample frequency 11025 Hz is 16 bits per sample, and total 55125 sample are obtained by our group. So with 11025 Hz, yeah, it's good enough for some interactive multimedia application and a low resolution for quality voice of sample rate. So next, our group successful to plot the signal amplitude of word M vs sample number N and discrete original word M, which has total 6141 of sample from the original audio, which is the word M are located at 2.08 second until
2.7 seconds. Then furthermore, discrete signal is decimated by 500 and amplified by 10 to reduce sample rate to 10 sample and amplify the amplitude. Which means lower the sample rate frequency response, the bit storage cause a reduction of a sound dynamic range. So the signal of the retrieved data need to be transformed into discrete signal before going through the decimation and amplification process. Besides that, the spectrum of the decimate signal are successfully calculated by using Z transform technique, and also the magnitude and phase spectrum of the signal. So we have concluded that the Z transform is useful for the manipulation of the discrete data sequence and has acquired a new significance in the formation and analysis of discrete time system. So overall for this project, we are able to analyze, study and investigate the problem actually by using MATLAB software and coding based on the theoretical approach and simulation work done. That's all for me and from our group. Thank you.